Right, okay, we're recording. Good. Okay, so the second part is the solving part now that we've made a model. So making a model is one part that we need in the standard. The other part is solving, which we've also been working on. So if we look, and we should have really read this over the read over the whole thing before we started, but anyway, that's fine. We haven't read this at all. This last part, there is a type of bacteria that's only bred in the geyser pool between 25 and 45 degrees. At that time, the geyser is closed. We want to use the model to find when both geysers are closed at the same time. Okay, so this is when our Desmos model is good because we can see both geysers. There's the simple one, geyser 1 is that one, and there's geyser 2 is the red one, and we can see how they both work at the same time. When one is up, the other one's not quite working in sync. There's sometimes where they're the exact same temperature and things like that. So what we have to do really is we need to look at figure out when one geyser is at those said temperatures and then the other, and then see where they match up. And the easiest way to do that really is to make a table, is to look at one at a time. So let's look at what we're calling geyser 1. So when it's between 25 and 45 degrees, so if we look at here, this is 10, so 25 is somewhere about here. This is 45 there, 55 there, so 45 somewhere about there. So we'll just draw a line. Cool. And so then we can see it's at 45 here, it's at 25 there, it's at 25 again here, it's at 45 here again. And because this is one whole period, we only need to look at that one whole period because it's just going to keep repeating every period. So it's going to repeat every 30 minutes. Okay, so we want to know it's closed between these times, so it's closed between 45 and 25 degrees, so it's closed along there. Once it's below 25 degrees, it's not cold. So again, once it gets up to 25 degrees, it's closed, and then once it gets above 45 degrees, it's open again. So there we go. So that's basically what we need to know. So we need to know this time, we need to know this time, and then we need to know this time and this time, because it's closed between there and there, and it's closed between there and there. Once we know those times, then we know all of the other times. And so now that's really easy to calculate. So if we're looking at here, we're going to put a y equals 25, y equals 45, and we can just click on here and we can see, there we go, 16.07 minutes, 18.5-ish minutes, and it's at 25 there and there. So it's closed between here and here, and between here and here. So the key thing now is interpreting that in context and showing what we're solving. So now if I just scroll, where did it go? Just a sec. Right, there we go. If we go over here, we see this is showing that we know what we're talking about. Now, when the geyser is at 45 degrees, so we're solving that equation equal to 45. Now, if I wasn't using Desmos, if I was solving it algebraically, I would get this one first, and then I would have to figure it out. But if we're just using Desmos, we're just going to straight away get these times. So we've got all of those times. Easy. There's the first time, there's the second time, the third time, continuing on. Now, if we have a look, this time here and this time here is what we read on Desmos. And then if you look at all the other times, we're just adding 30, aren't we? So 16 plus 30 is 46. And then the next time this is going to be repeated, that one, another 30. So every second one, that's just going to add 30 there. If we look on Desmos, we can see what's happening there. So the first time it's at 45 is there, and boom, boom. Oh, sorry, I don't think you can see my mouse cursor there. Okay, I just realized you can see my mouse cursor, so it's all good. Anyway, so that first point at 16, and then the next time it repeats itself, down, up, down, you can see is 30 seconds later, because that's the period. Down, up, down, 30 seconds. Okay, so we can easily read those off of there, but also just when we make our table of values, it's very easy to just find this one here and just go, so 16 plus 30 gives me that one, plus 30 gives me that one again. Okay, and then the exact same with this one. So at this point here, it's 28 seconds. It's going up, down, then up again. So it's repeated itself there. So that's where it's starting to go back up again after 30 seconds. And so the next one's going to repeat after 30 seconds. Hence why, again, 28, we just add 30, then we just add 30. Sometimes it's hard to know how many points to do, which is why we sort of go back to what's the question asking. Use the models of these geysers to find when both geysers are closed at the same time. So it's not actually telling us within a certain amount of time. So I don't know, we just look at a few, okay, to start with. And then of course the other times we're finding is when it's at 25, and it's the same thing. We're just finding when that equation equals 25, and then all we're doing is reading those first times off of Desmos, and now we're just adding 30, add another 30, etc. And now this one, adding 30, adding another 30, the same idea as that. Okay, so there's geyser 1, and so this means the geyser is closed, right, when it's between 45 and 25. So looking at that, between 45 and 25. So the geyser is closed between 16 and 18, between 28 and 26. Oh, that way it's the other way, isn't it? Between 46 and 48, between 56 and 58, right? Cool. And we look at geyser number 2, and again, geyser number 2 is closed when it's above 20, is it 25? Just about there. And when it's below 45, which just happens to be the mean, where it's at the middle. So we've already kind of got an idea of that. So it's closed again between here and here, and between here and here, between those values and those values. We're doing the exact same thing again, so I'm not going to re-explain that. Okay, and so then basically all we're doing is we need to show what we're solving. So we're solving when geyser 2 is at 45 degrees, which is at the mean, so I don't need to actually write the equation. And again, this is, if I was doing it algebraically, I would have found this and then gone there. But when I'm looking at it on Desmos, I get 27 and 57 is the first one, because now it's a good idea to just get that away. And there we go. So you can see it's 27, 57 is when it's at 45, and 32 and 52 is when it's at 25. So that's where 27, 57, and then at 25 I'm solving when that equation equals 25. So that's what I've read off Desmos, and then because I know the period is 60, all I have to do is just add 60, and I've got the next one, add 60, and I've got the next one. Of course, I can, and I do the same thing here, add 60, add 60. Of course, I can just read those off Desmos, but if we're drawing a big table like that, sometimes it's just easier to add 60, isn't it? So now, if we have a look at that, we can kind of write them together. So this is now my information, and you can see geyser 1 is closed between all of these times, and geyser 2 is closed with these times. Geyser 2 has a much longer period, so it's not closed as much. So let's sort of look at that. So 27 and 26, right? 27 is within this time period, right? 27 is there, and 28 is within this time period too, right? So that means between 27 and 28.93 seconds, they're both closed, right? Because after 28.93 seconds, which is within this time period, geyser 1's going to be open, but geyser 2's not. Okay, so now looking at this one, I just realized if I use my cursor, it's better. We got 52 to 57, it's close. So obviously between these times, only Geyser 1's closed. 52 to 57, well, here's 56.52 seconds, which is within this time period, right? And then 57 is within this time period. So only between here and here is there going to be any overlap. So that's why I've got it there. Okay, and then we can see Geyser 1's closed between 76 and 78, and Geyser 1 is open at that time, so there's no overlap there. Geyser 1's closed at 86.52, which is before 87, but then you can see Geyser 2 is closed at 87. 87 is between these times, and then we've got 88.93. Geyser 1's open, so it's only going to be between 87 and 88.93, where they're both closed. Okay, so within the first 90 or so seconds, these are the times they are both closed, right? And if we have a look on Desmos, this is when we can kind of see that when are they both between there. It's between here and here, and it's harder to see. You can kind of see that, but it's sort of actually easier to see if you write up this thing. Now, why does this pattern continue every 60 seconds? Let's just have a look and remember that this one here has a period of 30 and this one here has a period of 60 minutes, right? So every 60 minutes this pattern of these two is going to repeat, yeah? Because let's look here. This is the first time where they're both at the same temperature, and now if we keep it going here, not going to be at the same, and right there they're both at the same temperature again. You can see the picture, it looks the same, and that's after 60 seconds, right? And so that pattern is just going to keep repeating. If we go another 60 seconds, you can see here, now that's repeating, right? So every 60 seconds, it's going to be the same. So all of those times, these times here, where they are both closed, are going to just repeat it themselves every 60 seconds. So that's why 27 plus 60, that's why this is 87, right? And so this one I'm going to add 60, and that's going to be the next time where both of them are closed, okay? Which is why I've gone here, and of course now I figured that out in context, right? Because 27 minutes after midnight, of course, is 12:27 a.m. and I don't know why I've that's 20, should be a 29 there. And then 56 minutes after midnight is 12:56, so to 12:57. So that's when they're both closed, right? And that's going to repeat itself every 60 minutes. So it's going to repeat itself every hour. Okay, so this is, now we could make a generalized thing where it's going to repeat itself every, oh sorry, I've got a cat here that's really messing with me, messing with my computer. It's repeating itself every 27 minute of the hour, and every 28th minute of the hour it's going to be closed from there to there, and it's going to be closed every 56.5 minute to 57, okay, where n is every hour. Okay, sorry, this is hard to concentrate. I've got a small child and a cat messing with me. I'm not giving the best explanation for this. What I'm trying to say here, if n is 0, that will give me the first time, because 12 is like 0 on the 24-hour clock, so 0:27. Okay, and then 1 will give me 1:27, 1:56, 2 will give me 2:56, etc., etc. This is the general idea for what what we'll be doing at Excellence. Okay, we're generalizing it. We're looking at just what's happening forever. Okay, let's just, sorry, if we've just basically found some times where they're both closed, that's basically what you're looking at for merit there. Okay, I'm 10 seconds away from running out of time. I'm going to ramble no more. We'll talk about this more next week anyway.